Hello, we're going to be talking about lesson 8, collisions. Recall from what we learned on lesson 7. We said that every time when there is a collision, there's something that we know for sure is that the initial momentum will always equal to the final momentum. And then we've talked about two objects collisions, and most of the time that's going to be what we're going to be talking about. And when we do two object, we would have mass 1 and mass 2. And the prefix that we kind of would use, or the variable, is that we would have, for initial, the object 1 will have a speed of v1, object 2 will have a speed of v2, and then after the collision at the end, for the final, we would use the final velocity for v1 to be v1 with a little dash thing at the top. We call it the v1 prime, and then the v2 after the collisions, whatever direction it's moving or the speed that it's moving, v2 prime is what we're going to be using. And so to sum the two up, we are basically reviewing that for any types of collisions, okay? So all type, we will be talking about 3 types of collisions. If you want to just look ahead, we have an elastic, inelastic, and the third type is called completely inelastic. We're going to talk about that specifically. But what I wanted to say is for every single one of these, no matter what different kind of collisions, we are saying that the momentum is always the same. Okay? And so there's 3 kinds. The first kind is called elastic. Elastic collisions goes like this. The energy comes in, and they're telling you that the kinetic energies are always conserved. So what that means is whenever the questions mention elastic collisions, they already gave you 2 equations. Okay? They already gave you equation 1 is initial momentum equals to the final momentum. And when you see the word elastic, because by definition, an elastic collision, it means that its kinetic energy is conserved. So kinetic energy is EK, initial equals to final kinetic energy. And then we got 2 objects, right? So if I know that equation for kinetic energy is half mv squared, what we can write is that we know that the initial kinetic energies are made of the energy from the 2 objects, which is m1 and m2, and we have the speed initially is v1 and v2. So the kinetic energy initial would be half m1 v1 square. I'm just using this definition and the wordings at the bottom. And then the second object will have half m2 v2 square. That's the first side. And then how about the final? The final kinetic energy is referring to the final speed of the object. Your mass don't change, right? So for the 2 object, I'm going to have a half m1, but this time it's going to be v1 prime square, adding half m2 v2 prime square. Okay, it's not complicated. It's just disgusting that it has all these little dash and prime and all those stuff. Okay, all right, so that's the first kind. So that means when you're doing a question, when they mention this is elastic collisions, it means that momentum is conserved and kinetic energy is conserved, and they gave you the second equation. Okay, now moving on to the second type of collisions, we call that the inelastic collisions. Okay, like what we said just now, we always still assume that we have a conservation of momentum. So in this case, we still have P equals P prime. Okay, that's always true. Okay, but what does it mean by inelastic? Inelastic collisions is, you know how like the 2 object is moving and they smash into each other and then they keep moving. We have an assumption that some of the moving energy, the kinetic energy, is lost. So it's in the real world, elastic collision is a lot more common than the first kind, okay? Because we are going to have some sort of thermal energy, or if there's heat created, or if there is a sound. If you ever hear say 2 billion balls moving towards each other, the sound energy already would have converted some of your kinetic energy to something else. So that means the speed is not going to be maintaining at the final spot. Okay. So finally, the third kind is called completely inelastic collision, sometimes called completely inelastic collision. We actually did an example like this before already. Okay, this is when the two objects are stuck together. Okay, so what we can conclude is that we know momentum is conserved. That's what we know. So that means in the question, whenever they mention this is a completely inelastic collision, the first equation they give you is P equals to P prime. Okay, and then the second part is that when the two objects is stuck together, does it make sense that their final speed have to be the same because they're combined? So it's like if you have two objects and they lock together and they keep moving together. So a typical example is if I have a bullet shooting at a block. When the block and bullet are embedded, like when the bullet is embedded into the mass, do you see how they'll be traveling together? I don't have a second equation for this, but what I do know is that for the final M1 and M2, they have the same speed. So I actually have eliminated one extra variable, and that's what completely inelastic collision is. A chart summarizing it. Okay, notice any types of collision, no matter what kind it is that we've talked about, we have conservation of momentum. Okay, elastic tells you EK equals EK prime. We have a conserved of kinetic energy. We don't have an extra equation for inelastic collisions. We actually probably wouldn't do any math in terms of inelastic collision. Okay, we'll probably be only talking about conservation of momentum. And finally, the third kind, completely inelastic, we have V1 equals to V prime, V1 prime equals to V2 prime. So usually I would just go in and drop the 1 and 2. And this time I'm going to start with question number 3. So please turn to question number 3. During a football game, a fullback of a mass of 108 kilogram runs at a speed at 9.1 meters per second east, is tackled head on by a defensive back of a mass of 91 kilogram running at a speed of 6.3 meters per second west. What is the speed of the pair just after the collisions? Okay, so come back to the definitions, or what, like which kind of collisions are we talking about? So we got football player, one got tackled. What is the speed of the pair right after the attack? Okay, so is it elastic, inelastic, or completely inelastic? Okay, it isn't completely inelastic. So you're basically assuming that the two would be moving together, right? So they would have the same final speed. So similar to how I would do this question, I would do a chart first. Okay, the first player is moving at 108. Sorry, the mass is 108, and the initial speed or velocity V1 is 9.1. So V1 is 9.1 meters per second east. The direction matters because these are vector. Just like the rules before, you have to make sure that the directions are traveling the same before you can plug it in the equation. And then the other guy, M2, is 91 kilogram, and the initial velocity of the second player is 6.3 meters per second to the west. They're asking for what is the speed. So the final speed, I don't know what they are, but what I do know is that they are the same. All right, so change one to another. It doesn't matter if you want to go east or west, so you can decide, because whatever answer you got is whatever the direction you assume. Just like the projectile motion question, just like kinematics, okay? So I'm just going to assume east to be positive. So what I'm going to do is I'm going to change the west into a negative east, okay? And if you want to change west to be your positive and change your 9.1 to negative west, be my guest. Just know that whatever answer you got, the direction is east. And then if it's negative, you can turn it into a west. All right, so first equation that we always know in terms of collision is conservation of momentum. And I already talked about that. I need you to write out the first equation. Okay, so mass 1 and mass 2, the initial speed, and the mass 1 and mass 2, the final speed. So I still need you to start off with your equation. Okay, so this is still a 1 mark. I think I said it before, but I'm just setting the success criteria again. You must start off with that. And then from the table, I start plugging things in. There's no 0 in this question, but that's okay. I'm going to start plugging numbers in. Okay, okay, so I've just subbed in that the v1 prime and v2 prime is the same as v prime. So there's one variable. I can collect the like terms on the right hand side. So I have 108 and 91. So I got 199 v1 prime, v prime. And then I'm going to multiply everything on the left hand side. So 409.5, then divide both sides by 199 to get rid of the one in front of the v prime. So v prime worked out to be 2.1 meters per second. And we assume east to be our positive, so my answer is going to be in east. Question 4. A ballistic pendulum is the device that is used to measure the speed of the projectile, such as a bullet. The projectile of mass of m is fired into a large block, mass of m. So you can see on the picture here. Okay, so the whole point for this type of setup, so in a forensic lab, they actually use these types of systems to figure out what is the actual speed of the gun, because that way they can it might help them to figure out, how far did it shoot, or where was the location of the shooter, or the make of the gun. These are all indicators that they can get from it, and they have it set up. And basically what they do is they use a camera and then they observe the height that it's going to go. Okay, if they know what height this is, how high would it actually, when the bullet shoots here, how high would it lift up on the pendulum, then they can indirectly figure out what is the initial speed of the bullet to figure out whatever other crime thingy. Okay? All right, so let's keep reading. So as a result of which is blah 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 blah. Okay, of mass m, which is the suspended like a pendulum. Usually m is greater than m. As a result of the collision, so this is a collision. Okay, collisions happen right here, right? This is where so basically this part is the part that is the collisions. And what type of collision is it? First of all, you need to decide. When I shoot a bullet, it hits the block and they keep moving together. Do you see that this type of collision is a completely inelastic? Okay, so that means they gave me an equation like that. Okay, and then they asked you, they said that the pendulum projectile system swing up to a maximum height h. So I really should have just left that here. So it's going to swing up and it's going to be a height. Okay, determine the relationship of the initial speed v and the height h. Okay, according to the picture, they want you to find v naught and the h. Are we okay with what they're looking for? Okay, so 2 things. This is a 2-step question. If you want to pause this video and try it out on your own to see if you can figure it out, theoretically, you should be able to figure it out. This is you can totally do the problem solving. You've learned all the concept for this already, okay? But if you want to just listen on, be my guest, but try it. Okay, first of all, step 1 is we need to use the collisions P equals to P prime and figure out what is the V prime at the end for the block and the bullet together. And this V prime becomes the initial velocity of this conservation of energy question. Okay, so this is now your point A and this is now your point B. Okay, so it's 2 steps. First step, using completely inelastic, figure out what is the speed at the end before it rises up, because that gives you the velocity at point A. Okay, and then we assume at point A the height is 0. And then, I don't know if you get that, but when they say maximum height h, going back to kinematics, they wrote it out for you, but you should be able to pick it out, right? The velocity is 0. If I want to go above and beyond and make this a really good grade 12 question, I can ask you for the angle. Okay, do we remember or do we know how to do an angle for for a pendulum for conservation of energy? I can quickly cover it even though it's not in this question. I thought it would be a good thing to know, but we'll do that. Okay, so step 1, I do the conservation of momentum. So I'm going to do this chart again. It's always helpful. Okay, so I have lowercase m and big M. Okay, so M1 is the lowercase m, M2 is the bigger M. The initial velocity, the block was not moving, and I have my V naught. Okay, I'm trying to use the same prefix as the picture, which I don't like the way they label it, but I'm gonna say V1 is the V naught, the initial velocity of the bullet, and then the V2 initial velocity of the big block is 0, and then the final speed is the speed that is stuck. Okay, so final speed is V1 prime. And so we know that P equals to P prime. So M1 V1 plus M2 V2, initial velocity of the two objects, is M1 V1 prime adding M2 V2 prime. So I know that V2 is 0, so this is gone. And so this is lowercase m with the initial velocity of the bullet equals to the mass. I don't know if I'm going too fast, but are you okay that it would be the sum of the mass times the final speed? So I just factor out the mass because the speed have to be the same. Okay, this is how I got it. I should just write it. Okay, I know that m v prime adding m v prime is what I'm subbing in, so I just factor it out the v prime, and that becomes that. Okay, and so the relationship for v prime, if I isolate v prime on its own, because v prime, if we look at this picture, is what I have to sub in the conservation of energy, right? So I'm going to rearrange this equation as mvo all divided by m plus m. Okay, so that's the first part. Second part now goes about and talk about the conservation of energy. At the bottom, I'm going to redraw the pendulum, okay? At the bottom of the pendulum, which is point A, the height is 0, the speed is v prime, whatever the collision's velocity is. At point B, the height is what I'm looking for, and the v is 0 because this is the maximum height. Okay, so EA equals EB, and this time there's no spring at all, so I have total energy is kinetic energy plus potential energy, gravitational potential energy. You always have to start out with that, remember? And then now you cancel the 0. At point A, the height is 0, so EG is gone. At point B, V is 0, so EK is gone. So I have EK, which is 1/2 mv squared equals to mgh. And notice in this particular case, I can cancel the mass because the mass is both the sum of the two mass. I actually can cancel the mass in this equation. Okay, and what am I plugging in now? V1 prime is basically the speed at point A. So I'm going to plug in 1/2. The V is the V that I got. And I need to square that, equals to G times H. So this question is asking the relationship between V naught, which is the speed of the bullet that we get in here, to the height of how far it's going to go up. So it's going to help the forensic scientists know, if they know how high it goes, they can then go backwards and work out what V naught is. So I'm just going to quickly rearrange the equation for the V naught. You don't have to, because the question didn't really specify it, but we're just going to do it. So I'm going to bring the 2 over, and it becomes 2GH. Okay, and then because there is a square there, I'm going to take the root. So at this point, I have mv naught over m plus m. And then because I need to get rid of the denominator, so mv naught is going to equals to the root of 2gh multiplied by m plus m. Finally, get the small m over to the other side by dividing. I'm going to erase this guy. So this is the relationship. If I want to work out, say, this gun, I'm trying to find out what is the initial velocity when it hits the block. This is the equation that I'm gonna use. I know the G. The H is the measure height, so they probably take a camera thing. You know the mass of the bullet, you know the mass of the block, then you can work it out. Okay, so moving on to examples number 1. Okay, examples number 1, I purposely skipped this because this one has a bit more math involved. Okay, so they tell you that you have billiard ball, mass M, initially V1, undergoes a head-on elastic collision. So you're going to recognize that when it's saying elastic, is that my initial kinetic energy is equals to the final kinetic energy. And then don't forget, kinetic energy is half mv squared. Okay, with another billiard ball, same mass. So they're telling you that you have another billiard ball that is the same mass. And it initially was at rest. Oh my goodness. Highlighter, at rest. What are the final speed of the two balls? Okay, so I have M1 is the first billiard ball, which is M. I have M2, which is the second billiard ball, that's M. They're the same mass, so I'm going to use the same variable. Initially, it is traveling at V1, okay? But then this one, V2, is not moving. And then they're asking you what is the final velocity, V1 prime and V2 prime. Okay, so normally in the question, I know we didn't write it out, but normally this will be given. Normally, so we're assuming that we have the mass and we have that, but we have two unknowns. And every time when it's involved elastic collisions, you're actually dealing with two equations with two unknowns. I get my first equation here, right, which is my EE equals EK, because they told us is elastic. And then the other thing you need to hopefully know, we're talking about conservation of momentum. That means the other equation we have is P equals to P prime. Okay, so I have two equations that I'm going from, and those two equations will involve all the mass and the velocity, and we have to put two equations with two unknowns together. Okay, so that's basically why this is slightly harder, because don't forget we got the square here, so that means sometimes we're gonna have to do the perfect square and then expand out, do the FOIL and stuff like that. So before we move on further, let's just review that. Okay, if I have a plus b to the square, okay, you've learned this before, okay, I'm just going to be careful in showing you the expansion. Okay, so a plus b, if you are good in math, you might be able to just tell me that this is 2a squared plus 2ab plus b squared. Okay, if you can't do it in one step, expand it out like I did. Do the proper math procedures, right? So I have a binomial times a binomial, so that means I need to use the FOIL methods, right? The front, the outside, the inside, and the last. Okay, the front, a times a is a squared. O is the outside, a times b is ab. And then the inside, which is b times a, we're still going to put ab. We put it in alphabetical order as much as we could. L are the last, meaning the b times b, which is b squared. Collect your like terms. AB plus AB, that's why I'm able to say that is A squared plus 2AB plus B squared. Okay, people find this lesson hard because they forgot their math. But once we review it, hopefully you remember, it will come back to you. The format stays pretty much the same, right? I'm going to have P equals P prime. So I'm going to go in and make M1V1 plus M2V2 the same thing, okay? M1V1 prime plus M2V2 prime. If I drill nothing in your head, I'm still going to drill again. You must put this first equation. Even though there are some that are zero, some of the masses can cancel, we're still going to write the first equation first. Okay, V2 is 0. Oops. V2 is 0, so this term is gone. All the masses are the same, so all the mass can cancel. So at this point, I have V1 equals to V1 prime plus V2 prime. Okay, this is a known number. Okay, and I'm going to say the question will say 25 or something. So I need you to first of all do the same thing, isolate for one of the unknowns. Okay, I want you to isolate either V1 prime or V2 prime because we're preparing it to sub it into the other equation. Okay, and it's up to you. Okay, sometimes it's good if they have numbers, you might just want to clean up one so that you don't have to deal with the numbers in the FOIL, but it all will work out the same. Okay, so I'm just going to rearrange the equation for V1 prime in this case. Okay, so V1 prime is V1 minus V2 prime. So this is equation number 1. Okay, now I'm going to prepare equation number 2, which is from the kinetic energy. Okay, because the question says it is elastic collision, I can say that I'm going to do it at the bottom here because I want a bit more room. Okay, so EK equals EK prime. Okay, EK would be the kinetic energy for block A and B. So kinetic energy is half mv squared. So I'm going to throw in the m1, the v1, and all those stuff. Okay, 1/2 m1 v1 square, the kinetic energy for the first ball initially, and then the initial velocity for the second block will give you 1/2 mv m2 v2 prime. And then now I'm going to do the final 1/2 m1 v1 prime square, adding 1/2 m2 v2 prime square. So basically I'm just doing the kinetic energy for each of the block. Okay, so now I can start canceling again. And v2 is 0, this term is gone. I have halves in everything, all the halves can go. M are the same because m1 and m2 are both m, so I can take out all the mass only if they're in the same term, right? So I, at this point, have v1 square equals v1 prime square, adding v2 prime square. This is my equation 2. Okay, so the next thing we're going to do is we're going to sub number 1 into number 2. Okay, so I'm going to put equation 1 into equation 2. So equation 2, I'm going to rewrite it at the top here, equals v1 prime square, adding v2 prime square. So sub in number 1, equation number 1 is instead of v1 prime, I'm going to plug in the equation 1, which is v1 minus v2 prime to the square, adding v2 prime square. Now I'm going to have to be careful when I expand out the binomial with the square. I'm going to have to go through what we did just now, and just like remember this one, right? The a plus b. So I'm going to have to square up the front of the terms and the back of the term, and then I'm going to multiply the a and the b and times it by 2, right? So that's a format for a perfect square. If you can't do it in one step, just expand it out. I'm just going to plug it in as one step, okay? So v1 square equal expand out this, it's v1 square minus 2v1 v2 prime adding v2 prime square plus v2 prime square. All right, collect like term. I'm going to expand out the brackets. This is just a plus so the bracket can go. I'm going to rewrite it. Minus 2v1 v2 prime adding v2 prime square adding v2 prime square. Okay, take a look at your like terms. The first set of like terms that I see is a v1 square and a v1 square. I'm going to bring this over by minusing. Okay, do you see how that's gone? But I'm still going to write it out. I just want to make sure you're following. So v1 square minus v1 square equal negative 2 v1 v2 prime. The other like terms that I see, it's v2 prime square plus v2 prime square. Do you see how that's 2 adding 2 v2 prime square? v1 square minus v1 square is 0. And the other thing that I wanted to do is I want to factor out a v2. Okay, well, I'm trying to find the roots, right? So what I'm going to do is I'm going to factor out my v2, so one of them. Okay, so I'm going to take a v2 prime, factoring it out from the binomial. So I have minus 2v1 adding 2v2 prime. I took out a square, right? Okay, so that's the root. So that means if anything this equals to 0, it will make the whole term 0. Or if this is equals to 0, it will make that whole term 0. So that means I have two solutions. If v2 prime equals to 0, or negative 2v1 adding 2v2 prime equals to 0, solve for your v2. So bring the minus 2v1 to the other side. So I have 2v2 prime equals to positive v1. Divide both sides by 2. v2 prime is equals to v1. So I got two solutions here. Solution 1 is the distribution of the speed will be v2 prime. The final velocity of object 2 is 0. Or if the final velocity of object 2 is the same as the original velocity v1. Okay, so then finally plug it back into one of the equations. So if I'm going to plug it in and figure out if v2 is equals to that, what is v1 prime then? The final velocity of the first ball. So I'm going to have to solve for this last one because that's my other unknown. So v1 prime is v1 minus v2 prime, which is 0. So it equals to v1. So final velocity is this. So this is a set of solution. Okay. So the other set of solution is plug it back into the same equation. Equation 1, v1 minus v1, meaning equals to 0. That's my other set of solution. If you're feeling to take a deep breath and you feel that it's like, oh my goodness, what did she just do? It's normal because we're dealing with so many different math. But when I do it the second time, you'll be like, oh, it's the same thing. Okay, the format, I need to do the square. I need to solve for the v1 prime. It'll be a lot more manageable once you've been through it once. All right, so just write the general rules. Every time when we have elastic collision, this is what you do. Number 1, you do your chart. Number 2, you write your conservation of momentum equation. And then from there, you isolate the equation for v1 prime or v2 prime, is up to you, but one of the unknown, you isolate it first. Okay, and then number 3 is you write your conservation of kinetic energy, because that's also given. When they use the word elastic, they gave you that equation. Okay, and then you, after you clean it up, then you would sub your v1 prime equation into equation number 3. Okay, and then you solve for it, and yeah, and then you go from there. So hopefully this gives you a little kind of step thing that you would use. I might have to erase it after. I might not have enough room. Okay, so a super ball of a mass 2.5 kilograms rolls along the table at 2.3 and collides head-on with a stationary super ball of mass of 2. The collision is elastic, determines the velocity of each of the ball. So two unknown. Okay, so let's do our chart. All right, so mass 1 is 2.5. And it was traveling at a velocity, so V1 is 2.3 meters per second. And then the second ball is at rest at 2. So V2 original speed is 2. And this is your initial. Okay, and then the final, we're just going to make up the name. Make this a little bit longer. So final is my unknown. I don't know what each of them are, so I'm going to call it V1 prime and V2 prime. First equation, conservation of momentum. So P equals P prime. Initial momentum for ball 1, initial momentum for ball 2, final momentum for ball 1, and final, and final momentum for ball 2. Plug in my numbers, cancel my zeros. Oh, I totally made a mistake. Oh, no, yeah, I totally made a mistake on the chart. Okay, this is 0. I'm sorry. 0 meters per second. Okay, so this is gone. M2, V2 is gone because V2 is 0. So plug in what I know. 2.5 V1 is 2.3 equal to 2.5 V1 prime adding 2 V2 prime. Okay, so plug in your number. 2.5 times 2.3 is 5.75. It equals to 2.5 V1 prime adding 2 V2 prime. All right, clean it up, V1 or V2, that's up to you. I like to pick numbers that are cleaner. So let's try to take 5.75 and divide it by 2.5, and it worked out to be 2.3, so that looks okay. So I am going to choose to isolate for V1 prime. Okay, so this is what I'm isolating for. So rearrange the equation. I'm going to first of all subtract this on the other side. So 5.75 minus 2V2 prime is equals to 2.5 V1 prime. Divide both sides by 2.5. So don't forget, you need to do it for both terms, right? I'm going to write it out. Okay, so now this is gone. So this 2.5 is gone. So I'm getting V1 on its own. Then I'm going to work out what each of them are. So this is 2.3 minus 2 divided by 2.5 is 0.8 V2 prime. This is V1 prime. I'm just going to rewrite it nice in another color so I can easily spot it out. Let's do the green. Okay, V1 prime. I'm just going to put it on the other side. 2.3 minus 0.8 V2 prime. So I am right now at this step, right? I've wrote out P equals P prime, solve for what V1 prime is. Okay, so this is my equation number 1. So equation 1. Okay, gonna repeat the process, but now this time for the EK equals to EK prime. Okay, so I'm going to go EK is equals to EK prime. So initial momentum equals final, initial kinetic equals final kinetic. That's now step 3. Because you know elastic collisions, the definition for elastic collisions is none of the energy are lost. They all stay as a velocity, a speed type of energy. Okay? So 1/2 m1v1 square adding 1/2 m2v2 square is going to equals to 1/2 m1v1 prime square plus 1/2 m2 v2 prime squared. Okay, all the halves can go because the half is in every single term, so I'm going to cancel them. So all the halves all the halves can go. Okay, the other thing that can also go is v2 is 0, so this term is gone. All right, so let's see what we have left. Let's start plugging in our numbers. So m1 is 2.5. v1 square, v1 is 2.3 to the square, equals m1 v1 prime square, adding m2, which is 2, v2 prime square. Expand out the first term, so 2.5, so I'm going to multiply this out. 2.5 times 2.3 to the square, 13.225 equals to 2.5 v1 prime square, adding 2 v2 prime square. Now is math. It's up to you how you want to make it easier or harder. When I see that I have a v1 prime square and I'm supposed to plug equation 1 in, I am just going to look ahead of the game. You don't have to, but I am going to see what if I divide everybody by 2.5 just to reduce it and make it cleaner. So I'm just going to try out 13.225. If I divide that by 2.5, what would that look like? Okay, it's a 5.29 equals to, I've gotten rid of this 2.5, so I have v1 prime square. But if I've done that, I also have to divide this last term by the 2.5. Okay, so that means I'm going to take my 2 and divide it by 2.5. So I'm just going to make a little note on the side just so you know how I did that. So what I've done here is I've divided everything by 2.5 with all of them. Okay, so that every single term has been reduced by 2.5. And we already know what 2 divided by 2.5. We did that for the other equation. It is 0.8 v2 prime squared. Okay, I'm just cleaning things up because I've done it 1,000 times. I want to keep. Okay, so now that I've cleaned it up a little bit, I'm going to sub 1 into 2. So I'm going to take number 1 and we're going to sub it into the v1 prime. So 5.29 equals to, so instead of v1 prime, I'm going to sub in the equation 1, which is 2.3 minus 0.8 v2 prime to the square. The biggest, easiest, most common mistakes are the squares that's been missed. Okay, expand it out. I'm just going to do the full work here. I just want to make sure we're still all good in terms of how to expand. So I'm just going to write 2.3 minus 0.8 v2 prime. We're squaring it. It's a binomial. Okay. FOIL, FOIL. So 2.3 square is 5.29. Okay, that's forward. The front. Outside is 2.3 times negative 0.8, which is minus 1.84 v2. And then I have the inside, so negative 0.8 times 2.3, which is also minus 1.84 v2 prime. And then finally your last minus, and the minus makes a positive. So 0.8 times 0.8 is a positive 0.64 v2 prime square. Collect your like terms. Okay, so 5.29 minus 3.68 v2 plus 0.64 v2 prime square. Okay, so this is now going into as the expansion of what this is, the binomial of it. Okay, I'm just going to draw a little box around it. Okay, so now I'm sub it into the original equation. So 5.29 is equals to 5.29 minus 3.68 v2 prime, adding 0.64 v2 prime square, adding 0.8 v2 prime square. Whoosh. All right, let's see what happened again. I got a 5.29 and a 5.29. That's my like terms. I'm going to move this over. So 5.29 minus 5.29 is 0. You okay with that? Okay, so I just took it. They're the same. Okay, I have minus 3.68 v2 prime. Can't do nothing about it. But notice I have a like term, which is a v2 prime square. So 0.64 adding 0.8, I get 1.44. So it becomes a plus 1.44 v2 prime square. So I collected the like terms for v2 prime square. Factor out your v2. So 0 equals v2 prime. I'm going to factor them out. So I'm going to have left with negative 3.68 adding 1.44 v2 prime. So therefore, v2 prime is equals to 0, or negative 3.68 plus 1.44 v2 prime is 0. This is called finding the root. Okay, whatever v2 equals to, that will make it equals to, make the whole equation equals to 0. And I know anything times 0 is 0, so that's why if I can get this equals to 0, or if I can get this to be 0, then it will make the equation true. That's what the root means. Okay, so if v2 is equals to 0, I'm going to plug it back into equation number 1 so that I can figure out what v1 prime has to be. So this equals to 2.3 meters per second, so v1 prime, or figure out what v2 prime is. So 1.44 v2 prime equal positive 3.68. So I just moved the 3.68 to the other side. So 3.68 divided by 1.44, I got v2 prime to be equals to 2.6 meters per second. Find out what v1 prime is using equation 1. v2 prime, minus 0.8 times 2.6, 2.3 minus 0.8 times whatever the answer was. So it's 0.26 meters per second. I'm just going to double check. Minus 0.8 times, yep, 0.2. Oh, that's way off. Did you get 0.26? If you didn't round, can you double check for me? What this means is if I have a heavier block that was moving and then striking a lighter block that is not, I actually can have two possible scenarios. Okay, I could have the v2 prime absolutely didn't move at all. So telling you that ball 2 didn't start moving at all, and then the v1 will bounce right back with the same speed as before. Okay, and then the other scenario is v2 prime is 2.6, and then the v1 prime will move at a different speed at 0.26.